Hi everyone, welcome to the webcast How Immune is Our Application to Corona. Immunity is a state of resistance of an organism to invading biotic or abiotic viruses and their harmful effects. When we talk about applications, immunity becomes a state of readiness of an application to the unpredicted attacks on servers, networks, and different resources. Today, in these unavoidable circumstances, we are taking care of our own and our family members by staying and working from home. But today, we will be discussing about immuning our applications which do not have an option of hiding within four walls, but instead have exposed itself more than ever before. I am Rishabh Jindal, Product Manager at Cavisson. I bring in the experience of 6 plus years in product management and marketing. I completed my MBA from MDI Gurgaon and have done further studies from Columbia Business School, New York. Cavisson Systems is headquartered in Santa Clara, California, and is a leading performance intelligence platform provider that ensures exceptional customer experience and business efficacy of mission critical applications. With me today, I have Shashank Srivastav, Director of Product Management, Global Marketing, and Strategic Initiatives at Cavisson. He will also be the moderator for this webcast today. Thanks, Shashank, for your support. Before moving ahead with today's topic, let me also share some healthy guidelines for making this webcast a win-win for all of us. First, all participants to kindly mute. Q&A will be taken at the end. Share your questions with Shashank via WebEx chat. We all have locked ourselves in our homes, not just for our good, but also for the good of others. Our needs have not yet changed, but the method of fulfilling the same has drastically changed. We might have used to go to the nearby dairy shop for milk and bread, but now we might have shifted to buy it online from Country Delight or some maybe other. Well, I believe this is why such startups are still able to get funding by showcasing recent sales figure. We might have never imagined a day without reading the newspaper, but cannot even think of it today. Thanks to e-newspaper for not letting our knowledge down and still helping us to complete our daily morning duties. We might used to buy our groceries from local vendors, ration shops, or by visiting Big Bazaar, but are now preferring Big Plastic, Grocers, and others. All have different motivations to do this. Some believe in not going out of their homes. Some might prefer not to touch any goods before 3 days. No matter what motivation it is, but the outcome of all this is that we can expect a major digital transformation, not just for the youth but for all age groups. People will prefer not to go to high tech offices but work from home online, making Teams, Slack, and other capitalize on it. People will try avoiding Big Bazaar and avail similar discounts on Amazon Pantry. People will also prefer not buying gifts and cakes from stores but rather prefer arches online or fawns and petals and even more. Not just this, we no longer ignore health insurances, rather look forward to getting insured with one covering corona expenses. We even prefer to use e-wallets or QR codes instead of cash. Even as per the industry experts, the insurances and financial services which were previously dependent on offline channel partners are now taking a step to expand with digital partners or even self-expanding themselves, increasing the further scope of attracting traffic to their own portals. Well, for all these reasons, some are learning from their children or some are struggling themselves to learn how to order at pharmacy.com or how to shop order on Amazon Pantry. Even the banking sectors has seen a record high new net banking and mobile banking users. Marriages are postponed by months, but the search for perfect bride or groom have increased even more, with parents getting a chance to convince their children for marriage. Some are waiting for government to remove the ban of delivery of non-essential items so that they can be the first to order a new AC or a new phone or a new pair of shoes. This assures that no matter what, we foresee the boom in online shopping as compared to yesterday. But the question here is, are we ready for this surge? Now you might be thinking that I'm foolish to talk about this surge when financial markets will remain turbulent as a massive slowdown in economic activity due to the coronavirus takes hold across the world. But let me ask you, if this is true, then can you risk losing those customers who are there to buy your applications even in this downfall? If not, then stay with me for next 30 minutes to assure that you safeguard your business from repercussions of corona. Well, before that, let me remind you, the problem is not corona, but it's that no one across the globe was able to predict it and hence was unprepared for it. It's too late to do anything to stop the recession. All we can do is limit the pain, limit the damage. So, cutting it short, let me tell you what are we currently not doing right and how can we correct it in order to be ready for the unpredicted attacks which might occur on our application. I see an application in three different parts: resource, state, network. How confident are we in forcibly breaking something in production? For example, stopping the server in production when there is heavy traffic. We all are afraid of stopping something in production because we don't know what it will break as we have never simulated the scenario earlier. In the production environment, we may expect anyone or many of the following resources to be impacted at once and hence further impacting a number of metrics. CPU cores or utilization may suddenly increase. Disk space on the server may get filled. Input-output activity may get increased to a record break high. RAM utilization might unexpectedly get increased. In a similar way, one or more states can occur at once, again impacting numerous business metrics. Application may get aborted, cloud instance might get terminated, the server might get rebooted or shut down, server time might change to past or future. Not just the above, but even the following can happen with a network. Might be an unexpected packet corruption, or packet loss, or delay in network traffic, or even the DNS breakdown, or all ingress-egress traffic might fail. Why I'm focusing on these is because all of these leads to chaos, sales dip, revenue loss, leaving unsatisfied customers. Not only this, we force our loyal customers to enjoy competitors' extravaganza customer experience. We also allow our competitors to eat our market share and profits. Well, I don't think anyone listening to me today would ever like that to happen. To tell you all that how we can safeguard ourselves from these problems, let me share a real-time use case which recently happened with one of our esteemed clients. So this happens to be a situation when the client monitoring data at production environment says that their average CPU usage is 70% and they were happy enough thinking that they will still have a scope of 30% before any red alarm. But when during POC we decided to help them identify the tolerance capacity of their application, it happens to be only 85% average CPU usage. Unknown to this threshold limit, they were standing on the verge of facing heavy consequences if the traffic on the application had increased by a few percent. As we know, knowledge brings power to make wise decisions. I suggest you must look ahead to find which resource of your applications need a backup plan, or which state you are not ready for, or which network assault is about to happen while you are sleeping tonight. This will help you to be prepared with a vaccine before an attack like Corona takes over your application. Dropbox reduced its incidents by 10x in just 3 months by using chaos engineering methodology. Chaos and reliability sounds like opposites, so you may be wondering how this works. It's the practice of running thoughtful, planned experiments designed to reveal the weaknesses in our systems. By proactively testing how our system reacts to simulated real events like host failure, you can find and fix weaknesses before they become outages and effects. So we do experiments by creating production-like scenario and then inject evocs in that experiments to identify how does the application's behavior change when these kinds of situations happen. Using these kinds of experiment, we'll be able to identify loopholes in the system and hence will be further able to fix them. So that is how Cavisson's NetHavoc is useful to unfold the different issues which the application can go through with respect to the availability and deployment of the applications in a distributed system. NetHavoc helps you to identify fault tolerance capacity of your application. Let me tell you in detail how Cavisson can help to predict and analyze this outbreak. We inject something harmful to build immunity. Thoughtful planned experiments designed to reveal the weaknesses in a system. The primary difference with Cavisson's approach is that we practice by monitoring different information or metrics within the test environment by taking an approach of fault injection to test different conditions. We believe in the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. Our research on 100 plus companies with 250 plus respondents, including 25% CISO, 25% senior management, 30% managers, 20% performance engineers, resulted that whenever any unpredicted attack on application happens, 80% of the time, team says, we were not prepared for that. 90% of the time, team says, dashboards were lighting up, we didn't know where to look. 95% of the time, team says, alarms were going off and we didn't know why. How many times have you heard same comments after a production incidents? The absolute worst time to try and learn about the weaknesses in your socio-technical system is during an incident. There is panic, there is stress, there may even be anger. Today we are discussing a discipline that directly addresses systems availability and affects your culture, because we need to have a culture in order to make sure that nothing's break in production. And even if it breaks, then how can our application be handled? So it is nothing but a cultural change which we need to incorporate along with enhancing the capabilities of application to handle the situation. And even our infrastructure should be capable enough to handle such situations. According to the principles, our experiments typically consist of 4 steps. First, define the system's normal behavior. Its steady state based on measurable output like overthroughput, error rates, latency, and so on. Defining the normal behavior is very important because this will be further compared with the experimental group to understand that what difference do we have, and this difference and the size of the difference will actually build our confidence. The second step is hypothesize about the steady state behavior of an experimental group as compared to a stable control group. Hypothesis is nothing but coming up with a conclusion that this is how the system works, and if we will do something, this is how the system breaks, or this is how the system will behave in an experimental group. So, if we know that this is a particular process that is going to go down, then what will be the behavior of my client process? Will it be able to sustain, or will it be able to replay its particular message again? This is how we need to build the hypothesis around a steady state behavior and need to identify and set a goal. So the very important and the third step of the process is exposing the experimental group to simulated real world events such as server crashes, malformed responses, or traffic spikes. So we have a steady state, we have hypothesized that this is a steady state, and if we will do XYZ, then XYZ ABC will happen to our experimental group. Now we have a hypothesis and we need to test that. For validating, we need to do an experiment. So in the third step, we are doing nothing but doing an experiment and trying by implementing XYZ. So for example, we can have server crashes, traffic spikes, or anything, whatever we want. And we'll then observe the result. So for example, plugging out a server from the internet and then making sure that the server goes down and increasing the traffic, adding some failure events or adding some unexpected events in order to destroy the steady state of the application. Fourth step, test the hypothesis by comparing the steady state of the control group and the experimental group. So this is very important. Now we have a steady state and we have an experimental group. We know what we have in a steady state, we know what we hypothesize, we know what we have done in experiment. Now the results of the steady state and the experimental group are very important. Once we compare them, the smaller is the difference, the more confidence we will have that the system is reliable. But more is the difference means you need to prepare a backup plan, and that too now. So experimenting in production has a potential to cause unnecessary customer pain. While there must be an allowance for some short-term negative impact, it is our responsibility and obligation to ensure that fallout from experiments are minimized and contained. With this, I would like to say that Cavisson has a single goal: collect the evidence of system weaknesses before those weaknesses become incidents. Network help engineers build more resilient application. Our platform lets you run experiments in a safe, simple, and secure way. Here you can see the NetHavoc web app where a network attack is being on. Let's take a step back and take a look at some of the key components of NetHavoc. With NetHavoc, you can thoughtfully inject failure into hosts regardless of where they are, whether on the cloud or your own data center. After you have installed NetHavoc's lightweight agent on your host, you can then inject failure across 13 different infrastructure attack modes. Infrastructure layer attacks of NetHavoc fall into one of the three categories: resource, state, or network. While attacking resources of your application, NetHavoc allows you to consume specific amount of CPU, disk, input-output, or RAM. While attacking state, NetHavoc let you manipulate system time, shut down or restart host, or kill different processes. Finally, while injecting fault in network, NetHavoc allows you to inject latency to requests, introduce packet loss or corruption, and allows you to drop the traffic altogether. Even you can simulate a DNS failure by blocking access to DNS servers. Now let me take you through the short process of doing it. Step 1. Add Havoc in the test environment. As mentioned before, we have multiple categories, and in each category we have respective Havocs as per the possible type of attacks. We just need to select them with a single click.
give them a time when do we want to inject same, maybe right now or any specified time. Not only this, we can even plan how this increases in the system. For example, if we are adding CPU burst, which is to increase CPU usage to let's say 80%, then we can plan in how much time usage will increase to 80% level, or in how much time will it come down back to normal. All we need to do is to select a tier and a server on which we want to add this attack and configure it. Well, hooray, we are done. We can also create a scenario like daylight saving, give some description for it so that other users can understand while viewing it again. We can configure multiple havocs at one time in a scenario which creates a production time situation. You can precisely target the blast radius you want to attack, and if some unwanted issues arise, all attacks can be immediately halted, rolling your system back to a steady state in a single click. The results can further be analyzed in a descriptive reporting section. User can further drill down to analyze the data further. Not just this, we can check the monitoring reports to understand which all metrics were impacted and by how much. This graph validates that the CPU usage was increased within the set time. These are the further impacted matrices at the time when the havoc was added. CPU queue has increased to 200 during this time. Interrupts per second are almost double than the idle state. System CPU time and user CPU time have increased by 4 times with increase in CPU usage. These all metrics, when compared with an average CPU usage in production time, will lead to take a firm decision of our application. As said before, the smaller the differences, the more confidence we have that the system is reliable. But if not, and the difference is really more, means we really need to prepare a backup plan.
So plan your first experiment now by creating the hypothesis, measuring the impact, have a roll big plan, go fix it. And that's all. Have fun. Well, before moving to Q&A, let me share with you a discussion which I recently had with the CEO of a very large investment firm based out in Mumbai. What he cited out during the discussion was that while there is a slowdown, everything is moving slow. But the important thing is that they are still having customers being onboarded. They are an investment firm and they allow online trading to their platform. In fact, in the last 1 month alone, they have 10 times the usual registrations they receive every month. In last month itself, they had more than 10 times of the normal user onboarding typically do. And it was surprising for me, but that's the truth. In one of my slides, I reiterated that if you don't perform well in this opportunistic time, your competitors will enjoy it. And that is what exactly happens. Even though if I share my personal experience, I opened up an account on Zerodha, but I faced certain problems and I moved on to angelbroking.com. This is how things actually work. Not just this, word of mouth is one of the most impactful ways of marketing, and I just realized I made a negative impression for one of the known online stock trading company on your mind. Well, believe me, I just said the truth. Well, you pay for your competition if the things not actually work, which is a double impact. With that, let me open to any questions. Well, Sashank has shared me few questions shared by you all. Let me take them one by one. So first question is, which all operating systems are supported by NetHavoc? Okay. So, well, we have flavors of Windows, Linux, Polaris and other Linux versions too. Primarily mentioning the major operating system includes Ubuntu, CentOS, Red Hat and others. Well, coming to the next question, which all components can be attacked in the test environment to validate fault tolerance capacity of an application? Okay, well, that's an interesting one. So, as mentioned, we can attack multiple components of infrastructure layer. We divide it into three categories: resource, state, and network. All these major components can be impacted by network. The specified attacks we have for resources are CPU burst, disk swindle oblique search, IO shoot up, memory outlay, which can be added in the testing environment to monitor the impact on the system. Same way, in case of state, we see that there are four possible states of an application. Application may get aborted, or a cloud instance may get terminated, or the server might get rebooted or shut down, or the server might change to past or future. So for all these, we have different evokes which can be injected, namely abort application, terminate cloud instance, kill server, teleport. Also, we see that there is a high probability of unexpected packet corruption or packet loss or delay in network traffic or even the DNS breakdown, or all ingress traffic might fail. So all these situations can be created by following attacks in the test environment, namely intrude network, trim network packets, dormant network, DNS breakdown, interstellar. Okay, so the next question is, can we add multiple attacks at one time to simulate a real-time situation, and also can the attacks be scheduled for any specific time? Well, what I understand is that you want to know that we can test the cascading effect, that is, one attack leading to another or multiple attacks can be injected at one time, leading to degradation of multiple levels of infrastructure. Well, I'm happy to say that we have this option. And not just this, this is even a USP, that we are able to engineer and develop a capability to add multiple and even different type of attack at one time, and that to test a particular scenario. With their experience, we have seen that whenever it happens at production time, is that when there is one attack and it is huge, then it leads to impacting multiple points in infrastructure, further leading to impacting multiple metrics through which we analyze the scale of attack. So when we say that you can create a real-time scenario, then it is really important and interesting to run a mixed attack on different resources or different state or different networks. I believe this is a feature which is a must-to-have feature by any of the products competing within NetEvox landscape. I am glad that we have it much before anyone else have even thought of. Coming to the second part of your question, which is to confirm that can we schedule the attack. So let me tell you that with NetEvox, you can not just schedule an attack for a specific thoughtful time in future, but can also schedule for any random time by giving a specific range of time in future. So this is like we have three options for scheduling. Schedule now, that is to schedule a Havoc right away or in present. Schedule at specific time, this is to schedule a Havoc at a particular time in future, let's say 2 a.m. to night. Schedule at random time, in this we give user an option to schedule an attack at any time in the said range. For example, you want to add a Havoc like a surprise between 2 a.m. to 6 a.m. Then you just give this range and the Havoc will be added at any random time within this range by backing. So coming to your next question, how this can monitor the legacy apps built in a client-server technologies, EXE based and others. So if you have a distributed application architecture where an application works within a client server, so client server kind of architecture, let's say a two-tier architecture, so how can they monitor the legacy application in client server technology? So basically what happened is that you can still monitor because these legacy apps will be hosted on a certain hardware. Let's say server, so you can definitely have Havocs applied to the server. And then if the application is a legacy application, then there it's more of a client server architecture. You can still have the ability to do monitoring on the infrastructure side and on the client side. So we have monitors through which you can do the client side monitoring also. The client side monitoring will give you a picture into the user experience as well as the events
that might be happening over the client side. Now, these events are basically in test environment. Everything can be captured because we allow ability to use extensions to monitor. Now, if you are talking about EXE based applications, obviously we do offer SDKs, provided it's your own written code. But if these are of shelf application, then the client side monitoring on the thick line will obviously be little difficult, but we still have capability to monitor the client device itself, which could be a laptop or other. Well, that is one thing. The second question is that can the monitor be container based apps in the public cloud like Azure, AWS, etc.? The answer to this is yes. We definitely do have monitors for containerized applications deployment for Azure, for AWS, for Google Cloud, and so on. So we definitely offer that. Apart from the casual chit chat, when I mentioned the topic of my webcast today, he cited that even the so-called most impacted industry, real estate, is seeing in a raise of number of inquiries on residential properties by around 100% in the last 1 month. Well, I was happy to get that validated that I'm not wasting anyone's time today. So where some are thinking not to invest in assets, some are smart enough to foresee that this is a recession or slowdown which will be followed by a huge boom and hence are considering this an opportunity to make them ready for those days. This means it is us who can decide our way ahead. Halt every investment and wait to see how the market turns up in the coming months is one way. Or the second way is to be smart enough to use this opportunity in improving ourselves and our products, leaving our competitors far behind us. Choice is all yours. Well, thanks again for being with us and understanding what is best for your application to take precautionary measures and prepare itself for the coming surge. Look ahead to connect with you one-on-one via marketing team and further demonstration to your colleagues. Thanks for taking out time in these difficult times to learn how to safeguard your application from repercussions of Corona. Thank you once again.